It was a bright summer day in 1950. The brilliant physicist Enrico Fermi was walking to lunch with his colleagues. They were chatting about recent UFO reports, a fun little distraction from their serious work on atomic energy. Amid the casual conversation, Fermi suddenly posed a question, a simple question, a question so profound it still echoes through the halls of science today. He looked around at his friends and asked, "But where is everybody?" It wasn't a question about their missing lunch companions. It was a question about the cosmos. It was a question about everything we thought we knew about life and our place in the universe. This seemingly off-the-cuff remark would ignite decades of debate and become known as the Fermi Paradox. The power of Fermi's question lies in its disarming simplicity. It cuts through all the complex mathematics and astronomical observations. It goes straight to the heart of a cosmic mystery. If the universe is as vast as we know it to be, and if the ingredients for life are as common as we believe them to be, then the cosmos should be teeming with civilizations. We should see signs of them everywhere. We should see their starships. We should hear their signals. Or find the monumental artifacts of their long-dead empires. But we don't. We see nothing. We hear nothing. There is only a great, profound, and unsettling silence. This silence is the paradox, a deep contradiction between what we expect and what we observe. Imagine you are standing on a dark, deserted beach on a moonless night. You look up. A brilliant, shimmering river of light stretches across the entire sky. That is the Milky Way, our home galaxy. It looks like a band of light because we are looking at it from the inside, from one of its spiral arms. Now, try to count the stars you see. You might count a few thousand, but that is just a tiny, insignificant fraction of the whole. Our galaxy, the Milky Way, contains somewhere between 200 and 400 billion stars. Let that number sink in. Not million, billion. For every single person alive on Earth today, there are at least 30 stars in our galaxy alone. It is a stellar metropolis of unimaginable proportions. To truly grasp this scale, let's take a ride on our ship of the imagination. If we shrink our entire solar system out to the orbit of Neptune down to the size of a quarter, the Milky Way galaxy would be the size of North America. Our fastest spacecraft, traveling at incredible speeds, would take tens of thousands of years just to reach the nearest star system, Alpha Centauri. To cross the entire galaxy would take hundreds of millions of years. This incredible vastness is the backdrop for our story. It is a stage so immense that it seems impossible for life to have only performed its act once, here on our tiny, fragile world. The sheer size of it all suggests an infinity of possibilities. Every one of those billions of stars is a potential sun, a potential anchor for its own family of planets. For a long time, we could only guess if other stars had planets. But now we know. Our telescopes, like the Kepler Space Telescope and the James Webb Space Telescope, have confirmed the existence of thousands of exoplanets. We have found gas giants larger than Jupiter. Rocky super-Earths, worlds orbiting two suns, like Tatooine. The data suggests that planets are not the exception, they are the rule. On average, there is at least one planet for every star in the galaxy. That means there could be hundreds of billions, perhaps even a trillion planets in the Milky Way alone. This isn't just a numbers game, it's about real estate. Among this staggering number of worlds, a significant fraction reside in what astronomers call the habitable zone. This is the Goldilocks region around a star, not too hot, not too cold, but just right for liquid water to exist on a planet's surface. Liquid water, as far as we know, is the key ingredient for life as we understand it. So we have a galaxy filled with hundreds of billions of suns. We have potentially a trillion planets, and billions of those planets could be in the perfect spot for life to begin. The cosmic stage is set, the ingredients are in the cupboard, the oven has been on for billions of years, so where are all the chefs? Now we move from the scale of space to the scale of time. Our universe is about 13.8 billion years old. Our star, the Sun, formed about 4.6 billion years ago. Life on Earth began soon after. Complex multicellular life arrived much later. Modern humans, a few 100,000 years. Technological civilization, barely a century. We are cosmic infants. On a cosmic calendar where the entire history of the universe is 1 year, all of recorded human history flashes by in the last few seconds of New Year's Eve. Think about what this means. Stars and planets existed billions of years before Earth. If a civilization arose a billion years before us, where would they be today? Imagine the technological progress we have made in just 100 years. What would a society with a 1,000-year head start look like? Or a million-year head start? Or a billion? The mind recoils from the possibilities. They'd be to us like we are to bacteria. Their technology would be indistinguishable from magic, or even from the laws of nature itself. This line of reasoning is often formalized in something called the Drake equation. It was created by astronomer Frank Drake to break the big question into smaller pieces. The equation multiplies a series of probabilities: the rate of star formation, the fraction of those stars with planets, the number of those planets that are habitable, the fraction on which life actually arises, the fraction of that life that becomes intelligent, the fraction of intelligent life that develops detectable technology, and finally, the length of time such civilizations broadcast their signals. While many of these values are complete unknowns, even conservative estimates can lead to thousands or even millions of civilizations in our galaxy. So, the math seems to insist on it. The universe's age and size provide ample opportunity. The Drake equation, even with pessimistic inputs, suggests we shouldn't be alone. The galaxy should have been colonized many times over. An advanced civilization with starfaring technology could, in principle, cross the entire Milky Way in just a few million years. That sounds like a long time to us, but it is a cosmic blink. The galaxy is over 13 billion years old. Someone should have made the trip. Someone should have left something behind. A beacon, a monument, a self-replicating probe. Yet when we scan the heavens, the line is silent. The cosmic phone is not ringing. This is the heart of the paradox. Faced with this deafening silence, we must consider the simplest and perhaps most chilling explanation. Maybe we are alone. Maybe the extraordinary chain of events that led to life, and then to us, has only happened once. This is known as the rare Earth hypothesis. It suggests that while planets may be common, planets with the specific conditions needed for complex life are incredibly rare. Perhaps you need a large moon to stabilize your planet's axis, like ours. Maybe you need a giant planet like Jupiter in the outer solar system to act as a cosmic bodyguard, sweeping up dangerous asteroids and comets. Maybe you need plate tectonics to regulate the climate and recycle crucial elements. The list of potential requirements goes on and on. Perhaps the spark of life itself, that mysterious transition from non-living chemistry to a living organism, is an almost impossible fluke. We still don't know how it happened here on Earth, so we have no idea how probable it is elsewhere. Or maybe life is common, but intelligent life is the true rarity. Evolution does not have a goal. It is not trying to produce intelligence. It simply favors traits that lead to survival and reproduction. A clever primate is one outcome, but so is a durable cockroach or a simple bacterium, which has been wildly successful on Earth for billions of years. Perhaps intelligence is an unstable and ultimately non-adaptive trait. Let's take this idea one step further into a darker realm. This is the concept of the Great Filter. The Great Filter is a proposed barrier, a challenge so difficult that it prevents almost all life from reaching a highly advanced technological stage. The terrifying question is, where in the timeline of life does this filter lie? Is it behind us, or is it ahead of us? If the filter is behind us, we are incredibly lucky. Perhaps the jump from single-celled life to multi-celled life was the Great Filter, and we are one of the few, or only species to have made it through. That would make us special, the first to emerge into this silent cosmos. But what if the Great Filter is ahead of us? This is a much more sobering thought. In this scenario, life and even intelligence might be common throughout the universe. But at some point, civilizations reach a technological level where they inevitably destroy themselves. Perhaps through nuclear war, or uncontrolled artificial intelligence, or by ruining their planet's climate. If this is the case, the silence we hear is the silence of a cosmic graveyard. The empty sky is not a sign of our uniqueness, but a warning. It suggests that no civilization has ever survived the technology we are just now beginning to develop. The silence is a premonition of our own potential doom. But maybe the galaxy isn't empty, maybe it's just quiet. Another set of solutions to the Fermi Paradox suggests that alien civilizations exist, but they are deliberately hiding from us. Why would they do that? Consider the zoo hypothesis. To a civilization millions of years more advanced, we might be like animals in a nature preserve. They observe us from a distance, but they are careful not to interfere. They might have placed the entire solar system under a cosmic quarantine, a prime directive to not make contact until we reach a certain level of technological or ethical maturity. We are an exhibit, and the first rule of the zoo is, don't tap on the glass. Another, more ominous reason for hiding is the dark forest hypothesis. This idea frames the universe as a dark forest filled with hunters. Every civilization is a silent hunter creeping through the trees. In this forest you can never know the intentions of another hunter you might encounter. Are they peaceful? Are they hostile? It is impossible to be sure. The safest strategy, then, is to remain silent. Announcing your presence by broadcasting signals into space is a foolish and potentially fatal mistake. It's like shouting, "Here I am," in a dark forest where you know there are predators. The first civilization to be discovered is the first to be eliminated. In this scenario, the silence of the cosmos is not empty, it's terrified. There's also the possibility that we are simply too primitive to be noticed. A hyper-advanced civilization might not communicate with radio waves any more than we communicate with smoke signals, gravitational waves, neutrinos, something utterly beyond our imagination. Imagine trying to explain your smartphone to a medieval knight. Now extend that gap by 1,000,000 years. The difference between us and an advanced alien race could be so vast that communication is impossible. They aren't hiding, we're just not capable of perceiving them. They might be all around us, in other dimensions, or as pure energy, their existence as invisible to us as microbes were before the invention of the microscope. Or perhaps their motivations are simply alien. We project our own human desires onto the cosmos, the urge to explore, to colonize, to communicate. But an alien intelligence might have completely different goals. Maybe they have no interest in other life forms. Perhaps they have overcome physical existence and live in vast, simulated realities within supercomputers, exploring infinite inner worlds instead of the cold, empty outer one. They might have reached a technological singularity and transcended biology itself. The universe could be full of post-biological, super-intelligent beings who see our frantic search for contact with the same mild curiosity we might have for an ant building a hill. They see us, they just don't care. Let's consider another possibility. Maybe we're not alone, maybe they're not hiding, maybe we're bad at looking. SETI has run for decades, but in cosmic terms it's brand new. We've scanned the skies with radio for about 60 years. The cosmic ocean is vast. We've scooped out a single cup to check for fish. We're scanning a tiny number of star systems across a narrow range of radio frequencies. We may have simply not pointed the right ear at the right time. Think of the variables. We're listening for radio waves. What if they use lasers? What if they use neutrinos? What if they use something we can't imagine? It's like waiting for a drum beat while the galaxy uses fiber optic internet. Our tech may be too primitive. Even radio could be masked. Highly compressed signals can look like noise. A message might have passed 1,000 years ago or arrive 1,000 years from now. Timing must be perfect. We assume civilizations broadcast broadly. But why broadcast? It's energy intensive. On Earth, we're leaving TV antennas behind, moving to fiber optics and targeted transmissions. An advanced society would be more efficient. Their signals could be tightly beamed. We'd only detect them if Earth sat in that beam. The odds are astronomically small. The galaxy could be full of conversations we simply can't overhear. So the silence may be our limitation, not a paradox. We've just begun the search. We've built better telescopes. New instruments reveal the universe in new ways. The James Webb Space Telescope is analyzing exoplanet atmospheres. It's searching for biosignatures, methane, oxygen. The answer may come from a spectrum, not a hello. We are at the very, very beginning. So, where does this leave us? Standing in the quiet of a vast, star-filled cosmos with a question that has no easy answer. The Fermi Paradox is more than just an astronomical puzzle. It's a mirror. In asking, where is everybody, we are forced to ask, who are we? The different possible answers reflect our greatest hopes and our deepest fears. Are we the first children of the universe destined to carry the torch of consciousness out into the great darkness? That's an inspiring, if lonely thought. It places a profound responsibility on our shoulders, to survive, to cherish our world, to become worthy ancestors to a galactic future. Or are we one of an endless series of failed attempts? The idea of a great filter is a warning. It urges us to look at the challenges we face today. Climate change, nuclear proliferation, pandemic disease. Our ability to overcome them might decide if we are a footnote or the beginning of a long and wondrous story. The silence of the cosmos challenges us to be better, to work together, to ensure our survival if we truly are all there is. This question fuels our curiosity, which is one of the noblest parts of the human spirit. It is the same drive that led our ancestors to cross oceans, to climb mountains, to look up at the sky and wonder. The search for extraterrestrial intelligence enriches us. It pushes science and technology forward. It gives us a cosmic perspective. We share a single, fragile planet. The divisions that seem so important, our nations, our religions, our politics, fade when you contemplate the Milky Way. We are all Earthlings together on this journey. Do not be discouraged by the silence. The universe owes us no schedule. The story is not over. We are still writing it. Keep looking up. Keep asking questions. Stay curious. Nurture the spirit of discovery in the next generation, because out there, an answer may be waiting. Or perhaps the answer we seek is the one we create as we take our first steps into the cosmic ocean. The quest is the destination. Let's continue the search, together.